Hello learners, hope you are doing well. I have prepared a small revision on mid-latitude cyclones. The aim of the revision is to revisit geographical terms and concepts that you have learned through when you are studying mid-latitude cyclones. The revision will ensure that we accurately apply our knowledge during examination and also help to practice answering examination questions and become more and more familiar with the type of questions we might encounter in the upcoming examination. Let us begin. I will start with the question paper of November 2024, Geography Paper 1. Question 1.3. In this question, we are given a cross-section of a mid-latitude cyclone. The cyclone is in the mature stage. The cold and warm fronts are clearly visible. The clouds. We have cumulonimbus clouds just above the cold front. Cirrus and nimbombostrutus clouds just above the warm front. We are given the direction of mid-latitude cyclone from west to east. The first question, 1.3.1. In which general direction do mid-latitude cyclones move? Mid-latitude cyclones move from west to east, or you can say eastwards. Let's go to the next question. 3.1.2. Give a reason for your answer to question 3.1.1. Mid-latitude cyclones occur between 30 to 60 degrees latitude. It is in the same latitude that the westerly winds blow in. The westerly winds blow the cyclone from west to east, so they occur in the westerly wind belt. Question 1.3.3. How does front A give rise to the formation of cumulonimbus clouds? 4 marks. If you check on the diagram, front A is a cold front, is very steep. This steepness will help the warm air in the warm sector to lift very high. As the air mass is high, rise high, it cools and condenses, thereby forming the cumulonimbus clouds. So the answers are: the cold front will undercut warm air. Steep gradient cause rapid uplift of warm air. Cooling and condensation occur. 2 marks for each point. Let's move on to the last question of this question paper. In a paragraph of approximately 8 lines, explain the strategies that you can put in place to manage the negative environmental impact of the rainfall associated with the mid-latitude cyclones. I'm going to discuss with you 4 points. I want you guys to pause the video for a while and type in the comment section at least a strategy that can be put in place to manage the environmental impact of rainfall associated with mid-latitude cyclones. Okay, my first strategy will be to maintain natural vegetation. This means to protect the existing plant life in a given area. This includes to avoid human practices such as clearing the land, cutting trees unnecessarily. The next point is encouraging afforestation. This measure can reduce soil erosion. We can also buffer the area. Buffering is done in areas that are sensitive to protect them against harmful impacts. These areas can be rivers, can be streams, can be wetlands, or threatened vegetation type. This is done to reduce surface runoff, thereby slowing soil erosion, improving the water quality through by allowing infiltration and many other reasons. We can also use sandbags. Sandbags are very useful. They help to block and redirect flood water, thereby providing protection to the people and the houses in the area. Let us move on to the next question paper, November 2023. Let me start by reading the extract. Two cold fronts to hit Western Cape this weekend. Heavy rainfall to follow. The date, 10 June 2022. According to the South African Weather Service, two cold fronts are expected to bring rain, strong winds, high waves, and a significant drop in temperature to South Africa. The first cold front is expected to hit the Western Cape on Sunday evening, 12 June. Ahead of the first cold front, strong northwesterly to westerly winds between 50 to 60 kilometers per hour, gusting up to 70 to 80 kilometers per hour, are expected over the southern part of the Northern Cape and the interior of the Western and the Eastern Cape from Sunday. The second cold front is expected to reach the Western Cape by Monday evening, 13 June, bringing continued high amounts of rainfall, mainly in the southwestern parts of the Western Cape, especially from Monday to Wednesday afternoon. The wind direction associated with the cold front will change from northwest to southwest as the front moves over the Western Cape. The date is 10 June 2022, so it is in winter. Cold fronts are expected to bring rain and strong winds. The cold front will move in the interior from Sunday 12 June. The second cold front is expected to reach Western Cape on Monday, bringing continuing heavy rains. Let's do the first question. 1.3.1. In which season do cold fronts mentioned in the extract influence the Western Cape? Cold front pass over the southern part of South Africa during winter. The next question, 1.3.2. Give evidence to support your answer. The date in the extract can be a very good indicator of the season. The cold front in the interior. High amount of rainfall. Cold fronts bring lots of winter rainfall. Significant drop in temperature. Temperature drops when cold front moves in. The question needs one answer. The next question, 1.3.3. Why do cold fronts have a greater impact on the Western Cape during the season? Cold fronts affect South Africa during winter. This is because of the position of subtropical high pressure system. They shift southwards in winter, allowing the fronts originating from the Southern Ocean to move easily, reach the southern part of the country, bringing cold and rain mainly in Western Cape region, whereby in summer the high pressure moves further north, preventing the front from reaching inland areas as readily. The next question. The change in wind direction mentioned in the extract is known as backing, veering in the southern hemisphere. The key word in this question is southern hemisphere. When wind backs, it is taking an anti-clockwise direction, and this is common in southern hemisphere. Veering is a clockwise turn of wind in the northern hemisphere. If we check in the last paragraph on the extract, they say that wind changes direction from northwest to southwest. Is a change in anti-clockwise direction. Give a reason from the extract for your answer to question 1.3.4. So here is the reason from the extract. Wind will change from northwest to southwest. Moving on to the last question. In a paragraph of approximately 8 lines, suggest positive and negative impacts of heavy rainfall associated with cold fronts on the physical, natural environment of the Western Cape. Physical environment are all different factors of the nature, including the air, the trees, natural vegetation, lakes, ocean, etc. I'm going to list 2 positive impacts and 2 negative impacts. The first one is the rainfall will give moisture to the soil. The rainfall will revive biodiversity. Biodiversity is different kind of life that you can find in one area. These are the variety of animals, can be plants, even microorganisms like bacteria. They make up the natural world. Let's move on to the negative impacts. Low-lying areas will become flooded. Soil erosion will increase. Be free to add more that we did not discuss. Feel free to share in the comment section. Okay, let's move on to the last question paper, November 2023. The map shows the affected areas. The area is found in the south of South Africa. We are given a graph showing the average rainfall from 50 millimeters to 40 millimeters. Then the cross-section of the cold front, showing the cold ahead after the cold front. Question 1.3.1. The mid-latitude cyclone mentioned in the extract is in the initial or mature stage. Let's look at the cross-section of the cyclone. The cross-section is a good indicator that we can use to check the stage of the cyclone. The cyclone has a well-developed cold sector. We can see cumulonimbus clouds. This all shows that the cyclone is in the mature stage. The initial stage does not have all these features. The cyclone will just be starting. 1.3.2. Give a reason for your answer to 1.3.1. There are a number of reasons we can give. 1. A well-developed cold sector. Widespread rainfall. Because the cyclone is developed, the clouds can cover a wide area. A well-developed cold and warm sector. Presence of cumulonimbus clouds ahead of the cold front. 1.3.3. Why did the rainfall mentioned in the extract spread from Cape Town, Mossel Bay, and Knysna? Mid-latitude cyclones travel from west to east. So when the cyclone moves inland, it will start approaching Cape Town, then move to Mossel Bay and Knysna. The order of the movement is from west to east. 1.3.4. Refer to the graph and determine the lowest and highest millimeter of rainfall recorded in the Western Cape over 36 hours. The lowest rainfall recorded is 15 millimeters and the highest is 40 millimeters. 1.3.5. With reference to the cross-section, explain how a well-developed cold front results in heavy rainfall over the Western Cape. Well-developed cold front contributes to heavy rainfall by forcing warm moist air rapidly upward as the cooler dense air masses pushes underneath it, causing the rising air to cool, condense and form clouds that can produce a significant precipitation. 1.3.6. How would the heavy rainfall negatively affect the physical, natural environment in and around the Western Cape? The physical environment is the non-living part of the earth, the non-living parts of the earth, as well as the natural ecosystem that support life. They include the land-based ecosystems such as the forests, grasslands, the rivers, and many others. So the answers are: they will result in soil erosion, biodiversity will be destroyed, destruction of natural vegetation, loss of wildlife, fertilizers washed into the river causing eutrophication. These are some of the points you can list when you are answering this question.